is basically the force between two parallel current carrying wires. Okay, so normally we do know that when we have two wires that are parallel to each other and the current is passing by, so they passing by, so they attract or repel each other depending upon the direction of the current. So we will discuss that why they will attract and what sort of the force that one wire exerts on the other and the other wire exerts on the first one. So I think this article, have you already studied this article in FSC or not? Can anyone tell me?
नहीं सर, नहीं याद।
सर ऐसा आर्टिकल नहीं था, न्यूमेरिकल में था ये कॉन्सेप्ट।
अच्छा, चले, okay. So for that purpose, what he is saying कि he has taken two wires, ठीक है, and each wire has current in the same direction as that of the other, ठीक है. So here these are the two wires. Just hold on a second, beta. These are the two wires. One is this one and other is this one. Okay. So you can see here that the current is moving in the right direction, or you can say that in the upward direction. The direction of the currents in both wires is same here. So first of all, before calculating or driving the relation for the magnitude of the magnetic field, we want to see that what would be the direction of the magnetic field on the wire B due to the wire A here. Okay? And then we will calculate the force due to the magnetic field of the wire A, okay, on the wire B, and then the direction of the force. What would be the direction of the force? Basically, we want to know, okay, what sort of the force will be exerted by the wire A, which is lying in the magnetic field of the, wire B, which is lying in the magnetic field of the wire A. So you got the understanding कि क्या हम लोग करना चाह रहे हैं, or I should repeat it?
सर एक बार रिपीट कर दें।
Okay, we want to know what sort of the magnetic force will be exerted by the wire B, current moving by the wire B, due to the magnetic field of the wire A. This is what we want to determine. Okay, so later on it will get more clear to you. First of all, we will start with the wire A. So this is the wire A. So what would be the direction of the magnetic field on the right side of the wire? क्या होगी direction? What do you think? Into the paper or out of the paper?
Into the paper.
Into the paper. कैसे? ठीक है. We will take our thumb in the direction of the current, and we will curl our fingers according to the direction of the magnetic field. So the direction of the magnetic field will be upward in this side and will be downward in the other side. So it means that the second wire B, when we have a wire B, or the place where we have the wire B, the direction of the magnetic field will be in the downward direction, as it is clear by the green line here, which is showing that the magnetic field due to the wire A or the current IA is into the paper in the downward direction. So how we can find out the current is in the upward direction, magnetic field is in the downward direction. So what would be the direction of the magnetic force? क्या होगी?
राइट हैंड रूल से फाइंड करेंगे।
राइट हैंड रूल से, राइट हैंड palm रूल से. So we will take our fingers in the direction of the magnetic field, which is in the downward direction. Thumb will be away from you, and क्या होगा आपके पास? Normal of the palm will give you the direction of the magnetic force, which would be in this direction. यही होगी या it would be different?
यही होगी.
Okay. Anyone who didn't understand? Any question? Why we are getting in the force in this direction? Clear? Yes, sir. Okay. अच्छा, now coming toward the wire A. ठीक है, अब वायर A की तरफ आते हैं. In the wire A, ठीक है, we want to find out the magnetic force due to the magnetic field of the current IB, यानी second wire. Now अब इस IB की वजह से हम लोग find out करेंगे. So what would be the direction of the magnetic field on the left side, on the upper side of the wire B? क्या होगा? Out of the paper or into the paper? इस वायर की वजह से what would be the direction of the magnetic field? It will be like it will be downward in this direction while it will be upward in this direction. यही होगा?
Yes, sir.
Are you sure?
No, sir.
And why is it so, beta? You will take your thumb in the direction of the current that would be in this direction. You will curl your fingers, okay? So fingers will show me that curl of the fingers will show me that the magnetic field will be upward direction in the upper side of the wire B, and it will be in the downward direction in the lower side of the wire B. Now it is clear, beta?
Yes.
Okay. अब क्या करते हैं हम लोग के, so since we have the direction in the upper side of the magnetic field, we will take our fingers in the upper direction, ठीक है, in the direction of the magnetic field, and thumb will be pointed away from us. So the palm जो होगा, it will be along the right side, ठीक है. So normal of the palm क्या होगा? It will give us the magnetic force that will be toward the right side, ठीक है. So the direction of the magnetic force would be like this one. यही होगी या different होगी?
यही होगी.
Okay. Any doubt in the mind of any person? Should I go for the video call or is it clear to everyone?
Sir, video call कर.
Okay. Okay, see here. अब आपके पास, I am talking about the second wire. ठीक है, second wire would be something like this one. My fingers are in the direction of the magnetic field, which is in the upward direction. Okay, thumb is pointed in the direction of the current. So what is the direction of the magnetic force? Normal of the palm किस तरफ है मेरा? ये right side की तरफ आ रहा है. यही आ रहा है?
Yes, sir.
Yes.
So obviously the direction of the magnetic force is toward my right side. ठीक है. In the case of the scenario when the magnetic field was into the paper, अब आपके पास क्या है? हैंड जो होगा वो मेरा किस तरह आपको नजर आ रहा होगा? फिंगर्स आर इन दी डाउन, ठीक है. थंब इज पॉइंटेड इन दी अवे डायरेक्शन. ओके, सो मैग्नेटिक फोर्स इज टुवर्ड दी लेफ्ट साइड, ठीक है. तो लेफ्ट साइड ऑफ माई, मतलब माइन लेफ्ट साइड पे आएगा. सो आपकी मैग्नेटिक फोर्स की डायरेक्शन क्या होगी? इट वुड बी इन दिस डायरेक्शन. क्लियर? आवाज आ रही है बेटा?
जी सर.
Yes, sir.
Okay. So now you can see here that these two wires are exerting force on each other. So basically they are attracting each other. So it means when we have two parallel wires, okay, and they have the current in the same direction, they will attract each other. On the other end, if we have two parallel wires and the current is anti-parallel, means that one they are in opposite direction, current is in opposite direction. So in that scenario, like if current is here and if current is here, so they will repel each other. Okay, so this is the case. This is the force that acts between the two parallel current carrying wires here. So now we want to find out the magnitude of this force. Okay, what would be the magnitude of this magnetic force? So in the last article, what we have done that we have calculated the magnetic field due to the straight wire, and it was mu naught I over 2 pi r. यही नहीं था बेटा? mu naught I over 2 pi r था.
जी सर.
याद है? Okay, so here the distance between the two wire is d. So rather than taking r, we are now taking d here. So mu naught I our 2 pi d here. अच्छा, अब now first we have calculated the magnetic field due to the wire A. So the relation would be something mu naught I A over 2 pi d. So is it clear to everyone, beta?
Yes, sir.
Yes, sir.
Okay.
Yes.
So अब आ जाता है toward the second wire. So this magnetic field was in the downward direction, and now we have to calculate the magnetic force that has been. अब क्या हुआ, जब ये downward थी तो second current carrying wire, now it has been placed in the magnetic field of BA. ठीक है. So obviously magnetic force क्या होगी? So FBA force, ठीक है, it would be equal to IBL cross BA. ठीक है. IB क्यों? Because the current in the second wire is IB here. Magnetic field is BA here. So relation will be IBL cross BA. Clear?
ठीक हो गया सर.
Okay. So now we will just put the value of BA in this equation and putting the angle 90 degree because L and magnetic field are perpendicular to each other.
Perpendicular to each other.
So the relation would be something like this one, putting the value BA की value कहाँ से आई? We got it this from 2911, and this would be the relation that this is the force that the wire B is exerting on the wire A. So in the same way, we can calculate the force that wire A is exerting on the wire B here. So the ये जो है आपके पास force आएगी. ठीक है. Now from this whole article, it is clear to us that when we have the two parallel wires and they have the same direction of the current, then they will attract each other. On the other hand, if the direction of the current is opposite, so then they will repel each other. Clear? Any doubt or confusion about this article right now?
No, sir.
Okay, fine. Acha, so where we can use it? Okay, they have also mentioned in the highlighted region that parallel currents attract each other while anti-parallel currents repel each other. Okay, so where we can utilize is recently I don't know whether how much of your you like the military news or something like that, Navy or something. Rail guns. Have you ever come across this word, rail guns?
No, sir.
So recently, both US, two countries are basically advanced in the rail, and one is the US, other one is the China. China is, as per articles or the literature which I have studied, that China is much modern in the rail gun compared to the US. So rail gun is basically a simple two parallel. You have two parallel rails, and we pass the current through those rails, and the magnetic force it creates basically propels the body to move, or the to, you can say here, to projectile the material or any sort of the heavy material to a larger distance. Normally if we want to fire, okay, or if we want to hit a ship, just consider two ships. One ship want to hit the other ship. So normal procedure क्या है कि if they are close to each other, they use the deck guns. Deck guns use करते हैं in order to hit the other जो है ship. So if they are far apart, we use the missiles here, but if they are close to each other, we use the deck guns. ठीक है? So deck guns they act like a normal bullet, ठीक है, but in a heavier form. Okay, so rather than using the guns or the bullets or the bombs here, हम लोग क्या करते हैं, in the rail guns we take a heavy material, ठीक है, and we throw it with respect to by using the current here, ठीक है. So वो जो प्रोजेक्ट करते हैं, मतलब बॉडी जो है प्रोजेक्ट जिसको हम लोग थ्रो करते हैं on the other ship और हिट करते हैं जिससे अदर शिप को, that is basically moves at a very fast velocity, ठीक है. Normally it has a velocity of 10 km/s, ठीक है. अब होता क्या है बेटा उससे कि since they are moving very fast, so their penetration depth is quite high, and the cost of that projectile is very small compared to the heavy bomb we normally use by the deck gun. ठीक है? And how that rail gun works, basically क्या होता है कि we have two rails, ठीक है, and then there is a conducting fuse between the two rails. Normally it is of copper here. So when the high current passes through, like here you can see that the current is moving in the high velocity, and there is a conducting fuse between two rails. This is the conducting fuse, okay, that is connecting the two rails. So the current have a path to move to the other rail. So current will follow the conducting fuse, and it will move in the downward direction. So as a result, what will happen that ये आपके पास है, current is moving in this direction, and then current moves in the downward direction. So the value of the current is quite high because we are passing the large current. So as a result, the copper will melt down because it is a copper fuse. ठीक है, so it will be in the form of the conducting gas. ठीक है, so the direction of the magnetic field क्या होगी? So in each and every case, the direction of the field, अगर हम लोग देखें यहाँ पे when the current is passing here in the right direction, the direction of the field is क्या? Into the paper होगी. ठीक है, यही होगी ना, into the paper होगी ना यहाँ पे.
Yes, sir.
For this one, for the upward direction, it is also into the paper at the center. For the downward direction, it is also into
So
the
दोनों में
paper.
into the paper होगी.
And also for the right direction, it is into the paper. In all three sections, it will be into the paper. So it will create the magnetic force. ठीक है, magnetic force क्या होगी? So the current is moving in the right direction. Magnetic field is into the paper. ठीक है, as a result, what would be the direction of the force? ठीक है, you will take your palm in the upper direction, fingers will be stretched away from you, thumb will be in the right direction, and the magnetic force will be in the upper direction. यही होगा.
Yes, sir.
ठीक है, current is in the right direction, magnetic field is into the paper, so the magnetic force will be in the upper direction. Normal of the palm क्या होगा? In the upper direction होगा. So it will exert the force on this projectile body which we want to throw. ठीक है, as a result, what will happen that it will move out of the rail gun and it will move out at a very high velocity. ठीक है, since we are not using any sulfur here, so obviously it will be a quite cost-effective solution in order to throw the projectile on any other body. So any question up to this point, beta?
सर जब करंट पास करने के बाद जो मैग्नेटिक फोर्स वो इस ऑब्जेक्ट या प्रोजेक्टाइल को फोर्स करेगी ना कि मतलब
Yes,
स्पीड से.
obviously. Yes, obviously. Greater is the current, greater would be the magnetic force. ठीक है, as per ILB, if we will increase the value of the current, what will happen? Obviously, magnetic force will increase. ठीक है, so this is how it will work.
सर
Okay,
जैसे
and-
एक क्वेश्चन था.
जी जी.
जैसे हर चीज को मतलब टाइम लगता है कंज्यूम होने में, यूज होने में, सर वैसे ही करंट एक ही दफा सारा यूज होता है या उसको भी टाइम लग सकता है? मतलब एक सर्टन कि इतने टाइम इतना करंट यूज होगा या एक ही सेकंड में इतना टाइम मतलब हम करंट यूज कर सकते हैं?
बेटा बेसिकली the whole process जो है it takes place in milliseconds. ठीक है, this whole process takes place in milliseconds. ये बच्चा एक सेकंड बेटा होल्ड. ओके बेटा, अच्छा, normally this process takes place in a millisecond. ठीक है, and here we are not consuming the current. Here we are just flowing the current from one rail to the other, and when it flows through the metal this metal fuse here, which is at the center, at the bottom of the projectile, it will melt down and then vaporizes. So in obviously after that the movement of the current will stop by, and there will not be pass through it, ठीक है, because then there will be an open path. अब क्लियर हो गया बेटा?
सर ये जो प्रोजेक्टाइल है हमारा ये नॉन कंडक्टिंग होगा?
नॉन कंडक्टिंग कोई भी हैवी ऑब्जेक्ट हो सकता है, इट कैन बी एनी हैवी ऑब्जेक्ट, मतलब आप पत्थर ले लें, यू कैन टेक एनी, मतलब कोई भी आप हैवी ऑब्जेक्ट ले सकते हैं, ठीक है।
नॉन मैग्नेटिक होगा ना?
नॉन मैग्नेटिक भी हो सकता है, इट नहीं नॉन मैग्नेटिक नहीं होगा बेटा इन दैट सेंस, बिकॉज इट कैन आल्सो बी ऑफ मेटल, ठीक है। द थिंग इज के the path of the current will be lying up to this point, it will not be lying to any other point, ठीक है। अब यहाँ पे जब होगा there can be insulation between the walls and that of the projectile, ठीक है। So it will current, let's suppose if there is a rubber between the body and that of the rails, तो क्या होगा? Can current pass through it? पास कर सकेगा? नहीं कर सकेगा। तो obviously only conducting path that it had was basically this conducting fuse, which is now in the gaseous form, ठीक है। So it will obviously repel the current to it will eject the projectile to a longer distance. समझ में आई बेटा बात अभी, या शुड आई रिपीट इट? क्या हो गया, सारे खामोश हो गए हैं? आर यू गेटिंग माय वॉइस?
जी सर
आ गई। अच्छा अब आ जाते हैं एक सिंपल सा क्वेश्चन जो बच्ची ने किया था अभी। बेटा मुझे ये बताएं कि मैं भी थोड़ी सी आपको गलत शायद बात बता गया हूँ। एक पत्थर लेते हैं, कैन ए मैग्नेटिक फोर्स कैन मैग्नेटिक फोर्स मूव इट, ठीक है। आपको क्या लगता है मूव कर सकती है बेटा?
सर डिपेंड करता है अगर वो मतलब मेटालिक है या नहीं।
The thing is that the projectile should always be conducting. मैं बेटा आपको गलत कह गया क्योंकि पत्थर लेने हैं, sorry it's my fault, later on it come to my mind कि magnetic force only acts on the conducting material, ठीक है। So the projectile should always be a conducting material, okay?
Sir?
जी बेटा जी जी।
सर मैग्नेटिक फोर्स तो ये कॉपर के ऊपर एक्ट नहीं करेगी, तो कॉपर उसको पुश करेगा प्रोजेक्टाइल को?
नहीं नो। कॉपर इज बेसिकली क्या है कि फर्स्ट करंट विल पास बाय, ठीक है। नॉर्मल है कुछ भी, कोई देयर इज नो मैग्नेटिक फोर्स, जस्ट अज्यूम दैट वी आर पास current will pass through the fuse. What will happen that it will heat up, and it will heat up in a millisecond and it will get vaporized, ठीक है, in a millisecond. So क्या होगा when it will get vaporized, ठीक है, now there is a magnetic force that is acting. So this magnetic force and this gas will both repel the projectile out of the rear car, ठीक है। Should I go for the next article? Clear up to this point? So this is what it is written here. Now coming toward the second law, which is basically the Ampere's law. Okay, so what is Ampere's law and why we want to use it? Okay, normally when you already have studied in FSC, okay, when you have the electric field, you want to find out the electric field. So ठीक है, distribution of the charges due to the distribution of the charges. So you basically find out the differential electric field and then you add them by taking the integration, ठीक है। यही करते थे आप लोग। क्या आज सारे सोए हुए हैं मुझे लग रहा है। चले मैं आगे कैरी ऑन करता हूँ। अच्छा, क्या होता है कि when you have the electric field due to the distribution of the charges, what happens that if you want to find out the total electric field, let's suppose if I have a straight wire here, ठीक है, I have this straight wire here, so charge is uniformly distributed on this straight wire, ठीक है, so I want to find out the total electric field due to the charges on this wire, so what I will do is that I will divide it into the smaller elements, and then I will find out the electric field due to the one small element, differential element, and afterwards I will add them, I will sum them in order to get the total electric field due to the all charges that are present on this wire here or on this strip here. Okay, so basically we sum them up. But when the shape become complex, so it will become difficult to find out the net electric field. So for that purpose, what you have done in FS is that you have used the Gauss's law, and then you have used the Gaussian loop or the Gaussian surface for, let's suppose if you have cylindrical surface or infinite sheet. So what you have done in FSC, or what you have done, what you can do is that you basically take a Gaussian surface, and then according to of any symmetry which is suitable to you, and then you will differentiate it into the smaller elements, and later on you will sum them up in order to find out the net electric field. In the same way, if you want to find out the magnetic field, so the magnetic field is basically can be calculated due to the current length element that we have discussed in the last lecture. So if you have any arbitrary shape, okay, and which is quite complex shape, so first you will divide the arbitrary shape into the smaller elements, smaller current length element, then you will find out the magnetic field due to the each element, and then you will integrate them or sum them in order to get the total magnetic field. Now the problem is when you have a complex shape, this integration or the summation of the differential elements become complex. So in order to make it easy, we use the Amperian loop, or we use the Ampere's law in order to get the net electric field. Okay? So is it clear why we need the Ampere's law or why we need the Amperian loop? ठीक है, क्यों लेना चाहते हैं, क्या वजह, अभी तक आपको क्या समरी समझ में आती है कि why we need the Ampere's law? कोई बताना चाहेगा मुझे?
मैग्नेटिक फील्ड स्ट्रेंथ फाइंड करने के लिए।
टोटल मैग्नेटिक फील्ड स्ट्रेंथ, बिल्कुल ठीक है आपने। ठीक है, सो अब आ जाते हैं नेक्स्ट के हम लोगों ने क्या करना है कि वी वांट टू फाइंड आउट, ठीक है, ये कैसे करेंगे,
स्टार्ट करने टाइम ओवर हो गया।
चलें ठीक है बेटा, स्टार्ट कर लेते हैं। ओके।